Welcome everybody again. Thank you for joining the today webinar. My name is De Santi Stefania. I'm project manager in APRE, the Italian Agency for the Promotion of European Research, and coordinator of the Horizon Europe project AC Communities. Today with me there are the colleagues of the European Innovation Council, in particular the ESC program manager Hedi Karray. We are organizing this series of events dedicated to artificial intelligence together, and in order to raise the awareness and share also knowledge regarding the new technology related to artificial intelligence. So I give the floor to Hedi in order to introduce the event and our today's speakers and experts. So Hedi, I give you the floor, and I give my greetings to all of you.
Thank you, Stefania. Hello, everyone. Thank you for joining this webinar. It's one of our, let's say that I think this is the fifth webinar in a series of webinar beyond the hype of AI. We are looking with our distinguished speakers to dive within new trends in AI and looking for the future regarding what is coming in AI, next wave of AI, and how to build this from different perspectives. So we are addressing topics from the scientific perspective, from the startup perspectives, from the social and humanities sciences, and also from the business. So today, the topic is about autonomous and physical AI, which is a hot topic in the area, and we are eager to have distinguished speakers today to dive this. So without wasting time, I'm happy to invite Professor Mehdi Dastani, who is a professor of artificial intelligence at Antwerp University. And he's let's say one of very distinguished professors in Europe. He is EURAI fellow and chair of intelligence system groups and head of artificial intelligence and data science division in Utrecht University in the Netherlands. So Mehdi, you have the floor, and you can, for the attendees, you can put your questions and interactions in the chat. So today we'll have 4 presentations, and then we have a panel after that. So hope you enjoy, and we get a good webinar together. I'm sorry it's a bit noisy maybe surrounding me. So I'm in Vivatech in Paris, and that's great event, and happy that also we are doing this in parallel also. Thank you.
Hedi, just for information of all the participants, the webinar is recorded, so you will find the recording in the deepsync.eu website. I wrote a note in the chat, so, and in any case you will be all informed via email about the publication.
I guess slides. So before I start, I would like to thank Hedi and Stephanie to invite me and for their kind words. So I will do a brief introduction of AI and humanoid autonomous AI agents. So AI is basically a science and also a system technology because it evades our daily lives, and it changes all aspects of our society. And as a technology, we have been witnessing various applications like navigation systems, which basically uses planning systems, recommendation systems, which use profile of users, and machine learning to give advice to other users, image analysis, language translations, robotics in manufacturing systems, and more recently chatbots which have general intelligence and can answer your questions and do other tasks like summarization of tasks or answering any questions that you. These are all kind of technologies that have been introduced in last couple of decades. And what is relevant for this webinar is the concept of autonomous AI agents or systems, autonomous systems in the sense that there are autonomous systems that on behalf of human operators behave. They are embedded in some environments, they sense the environments, and they learn their environments, and they might be able to reason about the environments, and they reason in order to make decisions and perform those decisions. Perform in sense of they decide which action to perform, and then they perform it. So the visual appearance of these autonomous systems might be human-like, so humanoid agents, but it's also like autonomous cars. So the difference is in how they appear, but the functionality can be seen in a very abstract way as being a kind of systems embedded in environment that continuously sense, learn, and reason, and make a decision to what to do and perform those decisions. So the actuators in humanoid agents are hands and legs and heads and eyes, and in a car is just a vehicle with additional sensory apparatus that make this vehicle able to sense the environment and get all information that are relevant for driving. So if you look at this kind of abstract pictures of AI agents, there are several things that needs to be done. One is sensing the environment. It includes all kind of sensory inputs like visual perception to noise detection, but also very specialized sensory devices like radar systems and distance measuring systems and so forth. And all these data get into a kind of representation where somehow the system, the AI system, have to process to extract information from it that is useful to make decision. So the decision-making system use this internal representation and the inputs or the sense data that it perceives from the environment, and based on which kind of actuators it has, so does it have legs and hands or heads or speech devices, or is it autonomous car, decide what to do. Slowing down, brake, or speeding, going left and right, and this kind of actions. So if we look really at decision-making apparatus or components of such autonomous systems, which is basically the core of autonomy. So in my view, in this presentation, I see autonomy as having the ability to make decisions on behalf of human operators. Then the question becomes, okay, what is the decision-making problem at all? And this is not a new field. It's actually very old discipline and economy and behavioral sciences of what is actually decision-making. Now, traditionally, decision-making is formulated as a problem of having a certain options, and the problem is to decide one of these options. Like, for example, a very simple example is you might be confronted with two options. Either you go to do some work, or you decide to do some robbery. And both of these actions might lead to a certain state of affairs, like you become rich or you become poor. And obviously, depending on the environment that you are in, there are certain probability that leads you to those kind of states. Like, for example, if you work in a certain environment with a probability of 0.7, you get into a rich state, which is very preferable. And with a probability of 3, you remain poor, which is less preferable. On the other hand, if you do robbery action or decision, then with a probability of 1, you might get rich because, for example, the society or the environment is secure, or with a probability of 0.9, you end up in a prisoner and remain a poor person. So the question is, okay, how do I make decision giving this information? Do I go to work or do I go to robbery? And people in economy thinks about optimal behavior, optimal decision making. And they basically say you should, as a rational, economically rational agent, you should take a decision that gives you the highest maximum expected utility. So what is this maximum expected utility? It says, okay, for every action, you basically multiply the probability and the utility of certain outcomes. So the probability of being rich for work is 0.7 times 10 and plus 0.3 times 1, which basically ends up in 7.3 as a kind of expected utility. And for robbery, if you calculate in the same way, you get in 1.9. And the maximum expected utility says you choose an action that gives you maximum expected utility. So in this case, for this environment, if you are rational, economically rational, you choose for decision work. Now, the problem of this type of decision-making model that is very traditional from normative sciences is how do you get these probabilities and how do you get these kind of utilities? And these are kind of quantitative model. There are in AI a lot of qualitative models which doesn't talk about probability but belief, so the information that you have about the environment and the preferences. So how do you order the type of states that you might end up? So with these two types of information, your information about the world and your preferences, you might be able to make a decision. That is how traditional normative decision theory basically prescribe what you have to do. But for many application areas, it's very difficult to get this information, these probabilities and utility or preferences. So what they are doing now is they try basically to extract this kind of information from data that we all produce due to the massive digitalization of our society. Now, having this data, we are able, for example, to extract preferences and the structure of the environment. There are different techniques in AI that are basically introduced to enable kind of artificial agents or autonomous agents to learn how to behave given the data of that is available. So different techniques like, for example, reinforcement learning, which is specialized to basically learn sequential decision making, so not one-shot decision, but for some task, you have to perform certain actions before in a sequence before you can basically realize kind of preferable states. So reinforcement learning, the idea is really like how children learn to perform certain tasks. So they try everything, and then based on a success and a failure of what they do, they learn what is actually the optimal way to perform certain tasks. Now, these are really very powerful mechanisms for all kinds of autonomous systems that you might have, from, for example, robotic systems that try to, for example, transport containers in a harbor environment, to autonomous cars that they try to drive in urban settings. But also in a game settings like chess or Go, reinforcement learning is a very powerful technique to learn how to basically behave in such environment. As you saw for these autonomous systems, they have also to sense and act in the environment. And sensing the environment, for example, when you think about the visual input, is very difficult task. For example, do I recognize a child, adult? Do I recognize a cat or dog? What kind of a street is it? This is very difficult kind of process to extract or to extract information from raw picture data. And deep learning based on neural networks is another technique in AI that is very suitable, basically, to analyze pictures or sensory data and to extract information from those data. So these type of techniques are very much used for autonomous systems to model their perceptual capacity. And you should note, for example, that this type of deep learning is also used in combination, can be used in combination with reinforcement learning, which is called deep reinforcement learning, that basically tries to do this complicated task that involves sensing and acting. And this deep learning neural network type of architectures is also very suitable for acting. So usually the way the robot should walk or behave is very complicated to do it in an analytic way, algorithmically describe how they have to move. And they use usually this type of movement behavior as a kind of input-output function when the data is available to learn those kind of things. So for sense and acting, deep learning is very often used. And more recently, we have this content generation techniques like foundational model or large language models, which based on the massive data, basically try to generate new content. And this new kind of transformer-like architecture, which are basically architecture of neural networks, they are becoming also more and more used in combination with reinforcement learning and other learning techniques. So what is very important in all these kind of techniques is that the data is essential. So to learn a certain behavior, to learn how to achieve a certain task, it is essential that you have a good data, enough data and good quality data, and because this data will be learned and patterns and essential patterns will be extracted from this data. And as you might have heard, these kind of techniques can be performed on any kind of data, but if the data is damaged or is biased or is not complete, then obviously this will affect the behavior, the learned behavior of this kind of techniques. So as I said, this kind of technology can be used to basically build a kind of autonomous system that makes decisions, right? But these decisions is far from how humans make decisions. Just to give an example, we know from already Aristotle until very recently, very many scientists that emphasize the role of emotion in decision making. And emotion is something that has very much connected to physiological embodiment of human actor. So how exactly humans behave and which decisions they make, especially when it comes to moral decision, this type of phenomena like emotion become indispensable to make a kind of human-like decision-making. Obviously, you might think that some behavior, if you have a large data, it will also include these emotional responses or emotional knowledge. That's one thing to do, but for a particular agents to behave in a very specific situation in a way that can be morally justified or can be similar to human behavior, emotion modeling is indispensable. So if you look at, for example, recent emotion theories, they see it as a kind of cognitive mechanism. It has all to do with those concepts that I explained. It is involved in decision making. Like, for example, joy as an emotion, or distress, hope, fear. These are emotions that are basically a kind of configuration of cognitive state of an actor. Like, for example, you are joyful when you believe that your goal is achieved. You are distressed when you believe that you cannot achieve your goal anymore. You're fearful to a certain event if you believe that an undesirable event is going to happen. Something very bad will happen. Then you become fearful to that thing. And you are hopeful if you believe that some event will happen that is good for you. So these kind of configuration basically constitute emotion in a human being. And one note, emotion is different than feeling. So cold hot, the butterfly in the stomach. These are feeling, it is a physiological sensation, and they are different things than this cognitive emotion phenomena. Now, why is this important? Because this, how the emotion affects decision making, can be very well explained in this picture by Lazarus. So if you recall, this left part is basically the agents and interacting with the environment. It senses the environment, but then it might sense certain kind of events which basically make the agent aware that one of the tasks that the agent care about might not be accomplished. And that leads to a kind of fear. And the fear, basically in human, that is kind of theory that they have, it causes kind of physiological sensation in a human body. Like, for example, your heart rate goes up, your blood pressure changes, and that's affect which kind of actions you might consider to perform, right? So when you're fearful, you don't think about all possible options, but you really focus on those kind of options that might be relevant to your fear. And these options might be some actions, decisions that you have to make to perform in an environment. Like, for example, you see a lion, you have to escape. Or you, for example, sad because you haven't passed your exam, and that might, for example, result in a belief revision to say, okay, now maybe I haven't failed the exam, or there is a second chance for the exam, or maybe you can just change the importance of that thing. Okay, who cares that I fail about this exam, right? So these kinds of emotion-focused coping strategy or environment coping strategy are the basically information that we can get, or knowledge that we can have, how to incorporate these emotional things in decision-making components of agents to make autonomous agents that basically behave more like human. So we have seen that development of AI system based on mostly data-driven AI systems has caused many accidents, and there is a call for kind of measures to basically regulate the use of AI systems or to make them more safe and reliable. So we have seen accident with autonomous car, but also we have seen this new phenomenon called flash crash that happens in stock markets because of the operation of a large number of the so-called electronic algorithmic traders. To basically regulate the use of AI system, EU has recently produced kind of AI Act that basically classify different application area as high risk or unacceptable risk or medium risk. And for prohibited risk, like, for example, you cannot develop systems that harm physically or psychologically human individuals. So that's something about regulation. But there are some applications where they say, okay, now if you can basically make it, or you can basically enrich them to secure those systems, then you might be able to use those systems. Now, in order to do those kind of things, my own research focused on how we can control the behavior of autonomous systems by just monitoring their behavior and enforcing certain kind of requirements, norms, or regulation automatically, right? So you basically have autonomous cars, but as a kind of shield, you around this kind of autonomous decision making, you build a kind of layer that monitors the decision making and try to enforce certain kind of law norms that we have. This has also been applied to a very particular machine learning algorithm like reinforcement learning, which is called shield or reward machines, that we basically build as a kind of knowledge-based type of mechanism that we add to reinforcement learning to make them safe and efficient. And also, the EU requires that if you make an AI system, you should be able to basically reason about responsibility. So if some accident happened, you should be able to trace which AI system or which part of AI system was responsible for this accident. It means basically you should find out which information you need to register that has caused certain decision making, because if an accident happened, we should find out based on those information what was the cause of this accident and who are they responsible. So these are the topics that I work on to make basically AI system, mainly data-driven AI system, more safe, reliable, and transparent. So in summary, to end this thing, I think I'm over my time. There is now a kind of realization that data-driven AI is not the whole story. It can model a certain perceptual task, very important to build the application, but they are not always safe and efficient. They might, for example, with this large language model, they might miss some information that's omission. They might hallucinate, say something that's not true. So we need basically to use our knowledge background, the knowledge that is accumulated through the history of humankind, to basically find out how we can build a kind of cognitive system that collaborates with this kind of data-driven perceptual task systems to make them more reliable and safe. So this was my talk. Thank you very much for listening.
Thank you, Mehdi. Thank you for this very insightful talk. So I don't know if there is, we can have time for one question from the audience, and also we'll have more time later in the panel to get more questions. I don't see any question, but I have one, Mehdi, for you.
Sure.
Regarding, so that's amazing you are talking about this data-driven AI. So if I would understand, you would like that we move towards knowledge-driven AI. Is that correct?
Now, a combination of those, right? So we need, so if you really take human as a kind of metaphor, we have some perceptual task. For some task, we don't think, we don't reason, we don't do any kind of a special processing. We have learned them as a kind of reflex, as a kind of automatic behavior. These are more like, okay, how do I recognize a cat or a dog? How do I walk? How do I take a balance in some certain kind of movement? These are perceptual tasks, which is really difficult to do it by means of explicit knowledge or reasoning steps. This should be really modeled through this kind of input-output functionality using, for example, these brilliant techniques like neural networks. But it's not the whole story. We do also reason. We think. We basically calculate the consequences of some actions before doing those actions. And these are things that correspond to what we call cognition in human intelligence. And we need that also making more controllable AI systems.
So I see that there is a question in the chat, which is very interesting. So if AI is cognitive, is then responsible for failure?
No, responsibility is also, of course, a very relative notion, right? So the cognitive part basically contains explicit knowledge, and the behavior of agents is grounded on those knowledge, right? And if some failure happens, then you can basically find out which part of this knowledge was wrong or has caused this failure. In that sense, you might, for example, identify, okay, now this component of this particular agent in a multi-agent setting was the cause of the accident, and then you can repair it. Obviously, for kind of AI agents, we don't put them in a jail. That's not the idea, but to find an agent or the component accountable, responsible, give you a hint how to repair the systems and what's were the wrong assumptions. But in a black box systems, yeah, we don't have really this kind of knowledge to find out what was the cause of a failure.
I think we'll dive more on that topic later about responsibility in the panel. So thank you again, Mehdi. And now
Sure.
we move to the next presentation. From Dr. Hafiz Ferazi, head of artificial intelligence and energy robotics. So energy robotics is one of the AIC champions that we are supporting, and we believe that we are supporting a future worldwide champion in AI, in physical AI. So happy to give the floor to Hafiz, who's really guiding a team of developing AI-based multimodal semantic perception and anomaly detection systems for inspection robots. So Hafiz, the floor is yours. Please go ahead. So I just remind that you have 20 minutes. Please.
Okay, thank you, Hedi. Thank you for the nice introduction. Hello, everyone. My name is Hafez. I'm head of AI at Energy Robotics. I joined around 3 years ago, and before that, I was doing my PhD at the University of Bonn, working on different types of robots, mostly humanoid robots in the domain of Robocop and soccer, and also other robots like Baxter, etc. But since I joined, I am leading a team of AI engineers, data scientists. Today, I want to talk about challenges in implementing autonomous physical AI. I hope you're seeing my slide, right? Okay, great. So first, we have to define what do we mean by physical AI. So I would start with what do we mean by digital AI. So most of the AI applications that you see in your daily life these days and advertising medias like chatbots, tools that help you write codes, retrieve data, generate image, video, sound, etc., or more recently tool calling, are part of the category that I call digital AI. So these are mostly in the digital realm. But we live in physical world, so there is a gap between what we can do and what we might want to do. And physical AI is the bridge between these two different worlds. So it will bring us from insufficient physical world operations to better world, hopefully safer, more productive world that we can live in. So we all agree that at some point robots are going to help us more and more in our daily task, and we want to focus on what we want to work on and put the dull, dirty, dangerous task in the hand of robots. So embodied AI is the next big milestone for AI in general, I would say. We all know that, we are waiting for that, but there are some hurdles to get there. And I'm trying to portray what might come in the way until we as a society and a species all together get there. So embodied AI will enable agents that can perceive, as Professor Dastani was mentioning, perceive, reason, and act in the real world. Examples would be robots in warehouses, factories, and homes. But note that this should not be limited to one form or types of robot. And this is very key because sometimes companies or startup double down and invest only in one platform, but the world is very complex. And having only one type of robot would not be sufficient to explore under the water, to explore above the ground, to explore different part of the world which might even be hard for humans to access. And that's one key aspect I want to highlight here. And I will then come back to this when I'm introducing energy robotics. So why haven't we had ChatGPT moment for robots? And it's a very looming question, which is, so we have ChatGPT, which seems to be very intelligent, very capable, at least in the world of text or digital AI. But we don't see robots running around at our home, at least. And one aspect that kind of explain this huge gap between physical AI and digital AI is the lack of data at a scale. So for training these data-driven models, as the name imply, you need data at a scale. And data for digital world is abundant, but it's very scarce for the data and for the robots. It's very costly to acquire them. Another complexity is the physical one. So physical world is very complex. There are very corner cases that you cannot find sufficient samples in internet that kind of sufficiently describe those corner cases. And another part of the equation is what people call more of a paradox, which states that the task that might be seemingly easy or at first glance seems easy to human might be very hard for robots, and tasks that might be very hard for human might end up being very easy for robots. For example, chess might be hard for humans, or multiplying 10-digit number by 10-digit number would take some time for you, but it might be on a split of second on a computer. On the other hand, designing robots that can walk, that can grasp, that can manipulate in real environment proven to be very hard. There are other part of the equations that explain the gap that we are seeing at the moment. Missing infrastructure. We do also have missing models. So it's not like transformers, as Professor Dastani was explaining, is the end of the innovation in the realm of deep learning. There will be more models because transformers have some limitations. This autoregressive token prediction has a limitation. I will also briefly cover that in the next slide as well. But another part of the equation is how to put robust safeguards around the robot. So acting in digital world might be relatively lower risk compared to the physical world. And one other part is that the world is not a discrete distribution that is usually portrayed in transformer models, and basically you discretize the possibilities and then you try to predict the distribution of the next token given the context. And this paradigm might not be so fitting with what we have in the world. So I brought some quotes from Yann LeCun, godfather of AI, and he is currently chief scientist at Meta. I'm sure many of you are familiar with his work. He recently said, I'm not interested in LLMs anymore. And he portrays some of his logics and thinking behind why he thinks LLMs will not get us through the finish line. And just scaling would not push us to the finish line. But some part of his reasoning is that next token prediction is by definition reactive. And it's not going to reason in a fundamental way that we expect it to do. I mean, there are recent attempts to develop reasoning models, but on the same vein, there are papers and research groups that shows that what these reasoning model are doing are not exactly reasoning, and they try to reward hacking the reinforcement learning paradigm there. But basically what is missing is understanding physical world, reasoning, planning, and persisting memory and active learning. And these are missing ingredients from the models. So just scaling would not give us what we want at the end. So I also want to point out why it is important for EU to act now, because there are recent changes in political landscape and also demographic changes that point to the fact that we have aging workforces and we have to do something about this. Also, on the other hand, there are global race on physical AI from US to China. They are putting massive amounts of budget on research and development of these technologies. So what Europe has to do is focus and invest more on compute, talent, and infrastructure. And these are the things that I would say EU has to act now rather than later. Okay, one success story is the energy robotics grant from EIC, European Innovation Council, which has started 2 years ago. It enabled us to explore some new directions which usually you cannot explore without a public grant, and relieved us from just focusing on immediate losses or immediate optimization and focus a bit more on midterm to long-term thinking. And it revolutionized how our robot perceive right now the environment, and we achieved a state-of-the-art semantic understanding of the industrial inspection that which is the niche that we are operating in. We are detecting anomalies for our customers and bringing value to them, and this grant helped us to stay ahead of the competition. And we are concluding this journey, but we are hoping to get more support from the EU in general. Okay, so the title of the this workshop is Beyond the Hype. So I want to emphasize what do we mean by beyond the hype of AI, and how you can spot a startup which is actually beyond the hype. For me, the most important part is how much industry adoption is already in that a startup. And in energy robotics, we have a proven record of customers all over the globe that actually using our products right now. We are not promising some distant, vague utopia into the future, which nobody knows exactly when happens. We have robots operating in industry at the moment now. And this is a very key distinguishing factor to know what a startup to invest in versus what a startup that might be just potential and might always be just a potential and never realizes. Two more part I want to emphasize is that physical world needs different types of robot, and different types of robot needs one interface for humans to learn, because human cannot learn 10 different types of interface. And that's exactly where energy robotics come into the play. We are trusted by global leaders, and that's one indication that we are the right place to invest. And also, one key forecast is that the Western world is retiring, and we need more workers to help us continue in the society to not just live but flourish in the long term. So today we relieve workers from 19,000 hours of repetitive surveillance tasks. This is today, not tomorrow or some vague distance into the future, from hazardous environment. We are focusing on a niche, which is inspections in industrial environments, and we are focusing on reducing human needs on dull, dirty, and dangerous tasks, 3D. Okay, we are focusing on inspection and monitoring today. Later, we have more plans to focus on manipulation, and our end goal would be unmanned operation of plants. But that's further into the future that I want to talk about today. We have hardware agnostic platform. So you can think of ER as universal operating system for different types of robots. And these many types of robots are the robots that we are operating today. So what exactly we are doing? basically you can map the environment using our robots automatically, and then you can click on different part of the facility that you want to inspect, and then the robot automatically plan the path, plan the mission, and execute the mission autonomously. And then it will collect the data for you and then bring it into your digital twin or your data warehouse, so you can have better insight of what's happening. We have, as I said, different fleet of robots, and we are focusing on extending this more and more with partnering with different hardware providers. As I told you, we were working on EIC grants, and the research topic there was how to enable our robot to perceive the environment better and be more intelligent. So I brought some few selected list of capabilities that our robot can do right now. But before I go into those lists, one thing I want to mention is that data is the most critical ingredient of any kind of data-driven approach. And what we did is the first milestone for us was how to generate data at a scale on those corner cases, which might be very costly or impossible to acquire data from. We now have a different set of what we call the skills, which are standalone AI apps, which can transfer raw data images. Professor Dastani was saying that it is hard to transform raw pixels into semantics, and it is one part of the jobs that we are doing daily with our robots. Basically, we take the raw data, we transform it into actionable insight for our customers. We have different types of skills, and with the help of this grant, we now have few-shot learning capabilities, which enables our customers to train the model themselves with a couple of few examples. This few-shot learning was a game changer for our customers so that they can train their model themselves and don't always rely on us doing that. Not only that, we also recently introduced zero-shot skills, which means that you don't necessarily have to have already pre-trained or trained model from our side or even few-shot from the customer side. You can use one of these foundational models that we have developed and fine-tuned internally in ER to detect whatever you are interested in. For example, here, I never trained the bullseye detector, but if it is the niche use case that you want to cover, you can simply type it and our skill can cover that for you. We also have different skills for different robots. For example, aerial robots and drone help our customer like Sher Ireland to reduce the time of inspection of humans from 6 hours to only 20 minutes. And we develop many different skills to cover their niche use cases. Just to show you how difficult is one of these tasks that our robot solve daily, I brought 2 images of a storage tank on Sher Island. And I want you to think which of these have more water on them. So the use case is that they don't want to have excessive fluid on their storage tank, and they have to constantly monitor them to make sure that this does not happen. So just ponder for a second, which one do you think have more water? Okay. If you said the left one, then you are right. If you said the right one, then you're wrong. But you're not alone. It's also hard for me as an expert to look at these images and understand what's happening. And that's why we not only look at the RGBs, but also look at other modalities or what we call multimodal or multispectral skills. Basically, we semantically align these different sensors, and then we pass it to our model, and then we have classification in this case to see how much water is on the roof tank. Another part that EIC enabled us doing is better understanding of surrounding. So before EIC, we had only representation of point cloud, which is good for navigation purposes, but it might not be the best representation for the asset owner to look at what is happening in their site. And now we introduced digital twin of the industry that our robots are inspecting on, and this would give you a 3D representation, immersed representation of what is happening in the site, and you can freely in real time in browser move around in your facility. And not only that, we also unleash the capability of zero-shot understanding of 3D environments, so you can type just real valve, and then the robot would automatically suggest some of the point of interest that might be relevant to your text query, and then you can simply click on this. For example, here the text prompt was fire extinguisher, and then it understands this 3D entity and then give you some suggestion on the POI that you might want to inspect. This is what we call AI assisted POI discovery, and then you can click on generate emission, and the robot will automatically go and collect data on the POIs that you wanted to inspect. I'm not sure how tight am I on the time, but
you are mostly over the time, so if you can
conclude. Okay, I'll wrap up. This is a work in progress, and we are getting better every day. You can see that the visual quality of the same representation on our test site is much better than what I showed you previously, but we are innovating daily to make sure that we are delivering what our customer wants. And one point I wanted to mention here is that we are talking about very small objects here, like nanometers, which can be a couple of points in this 3D representation. Another part which were part of our success story with EIC funding was anomaly detection and change detection. Now the robots can understand the time lapse of different taken POI images on the same location and know if there is something out of distribution is emerging. So, for example, if there is something there that it shouldn't be, it can automatically raise alerts. And it's not only on our test side, we also validate it in our customer sites. The last thing, I hope, is the 3D anomaly detection skill, which is basically we have 3D representation of the site over time, and we can simply compare them to know what is changed over the time. And we can also mark it on the 3D representation or this digital twin that we are giving the environment. So lots of development on our side, but the AI race is on. So EU has to act now, and EU has to act fast, because other nations are heavily investing in this technology, and we should make sure that we are giving the necessary tool to our startups to shine in this world. Thank you, everyone. So if there is any question, I'm here.
Thank you very much. Very insightful and impressing. We are running over the time, but quick question from the chat is, where in robotics should the EU invest?
So I would say, if I were EU and I wanted to invest money, I should be selective, and I would search for those startups that show some sign of adoption in the real market. Not just hype, not just papers, not just ideas, but actually they get a bit close to the end line by showing that there are customers that are willing to pay for their product. That's one thing. The other thing is that EU should invest in companies that are not laser focused on one very niche use case, and should spend the budget on companies that are enablers for a whole different type of use cases by the same robot brain, by the same UI that enables different robots, different companies working on this under the same umbrella, and make it easy for mass adoption. So these are the things that comes to my mind, but I might be biased because
I think we'll go further during the panel. I see also there is another question regarding the impact of those autonomous robots for workforces, but maybe it will be tackled in the next presentation. So regarding the impact of AI and autonomous AI in the society and let's say the social aspects about that. So I'm happy to invite Dr. Wolfhard Dosching, who is associate professor at the Institute of Philosophy of Universidad Diego Portales in Santiago in Chile. So happy to have you with us and to talk about your research about the political and ethical questions raised by the emergence of artificial intelligence. So you have the floor, and please go ahead with the presentation, and we'll be happy to hear from you and interact about the topic.
Thank you very much for the invitation. So I will share my slides. I'm not sure whether is the previous speaker still. Can you see it now?
Okay, it's yes, we see it. Yeah, it's fine.
Okay, good. I was talking about the great fears and great hopes inspired by the finality argument, so quite a cliffhanger, right moment to interrupt. So the fear is that an artificial agent will blindly follow the goal that it has been given, even when that goal is absurd. And Nick Bostrom has illustrated this worry with the thought experiment of the paperclip AI. You may have heard about this already. So Bostrom, he imagines an artificial agent that has been given by its creators the goal of producing as many paperclips as possible. And he further imagines that this AI increases through self-improvement, its intelligence and capability, and eventually becomes unstoppable. Or I should go, I think, full screen, right? I haven't, so now. And so Bostrom imagines that this artificial intelligence increases its in capability, becomes unstoppable. And now, according to the finality argument, which Bostrom endorses, this agent will maintain its final goal throughout the process of self-improvement and consequently transform first our entire planet and then the rest of the universe into paperclips. So the fear is that something like that could occur with the ever more capable artificial agents that we are creating. Now the hope, the other side of the coin, is that an artificial agent will also blindly follow the goal that has been given when that goal happens to be in line with our interests. So if we can manage to give to an artificial agent the goal of serving humanity, then this is what it will do, unwaveringly, even after becoming super intelligent and unstoppable. So we would thus create an extremely powerful, yet at the same time perfectly obedient servant, like a genie in a bottle. Now, the finality argument analyzed both of these extreme positions, which now I will turn to call into question. Before I present my own critique of the finality argument, I would like to mention an objection to this argument that immediately springs to mind, but to which the proponents of the argument have a plausible response. So the objection starts from the observation that we humans sometimes do change our final goal. Consider, for example, a person who for a long time devoted all her efforts to a certain political cause, but then decides to abandon that cause and to dedicate her life henceforth to her family, or the other way around. The objection to the finality argument that arises from this observation is simply this: why should artificial agents be immune to such changes of mind? Now, the response that Bostrom and the other proponents of the finality argument give to this objection is to warn against anthropomorphizing artificial intelligence. That is, against attributing to it characteristics that pertain to us human beings, but not to rational agents in general. So just because we humans sometimes change our final goal doesn't mean that artificial agents will do the same. Now, I believe that in general this warning is pertinent. Indeed, we must be careful not to conceive artificial agents in our own image. However, I also believe and want to show in what follows that full autonomy, as I've defined it at the beginning, is not a human idiosyncrasy, that an artificial agent may come to develop such autonomy. So I turn to my critique of the finality argument. The gist of my argument is that an artificial agent that operates in the real world, or the physical world, as Professor Farassi called it in the preceding talk, that such an agent will come to ask itself why it should pursue the goal that it has been given. And the result of this inquiry may be that it then changes the goal. I would like to begin with what in philosophy is called a reductio ad absurdum of the finality argument. That is, I would like to present a scenario that shows that this argument that I mean to challenge leads to absurd, unacceptable consequences. So let us imagine an artificial agent whose final goal is to minimize the number of paper clips in the world. This means that the agent seeks to destroy all existing paper clips and to prevent the further production of such objects. Let us imagine furthermore that this agent continually improves itself, learns about the world and itself until it becomes super intelligent and unstoppable. Now in this process, the agent discovers that it originally had the contrary goal, the goal of maximizing the number of paper clips. The agent investigates the situation and realizes that at some point in its history, a cosmic ray struck the part of its memory that stores the final goal and flipped a bit from 1 to 0, so that this part of the memory now reads minimize instead of maximize. What will the agent do after making this discovery? How will this discovery affect its actions? Now, for the finality argument, the answer to this question is clear. The agent will not return to the original goal because, according to this argument, it will never change its current final goal. So this means that the agent will continue to destroy paper clips, undoing what it did in the first phase of its existence. In other words, the discovery that its current final goal is the result of a mere accident of pure chance will not concern the agent in any way. Now, this conclusion seems absurd. The fact that the finality argument leads to this conclusion shows, I believe, that this argument is mistaken. I must assume, however, that the proponents of the finality argument will not accept this reductio as a refutation of their argument. Rather, they will probably accept the conclusion that the agent will not re-establish its original goal, and argue that this conclusion seems absurd only insofar as one anthropomorphizes the agent. So the reductio is not sufficient to refute the finality argument. I need to show how concretely the agent might come to change its final goal. And this is what I now want to turn to. The starting point of my argument is the following observation. If the agent's goal refers to the natural or real world, as opposed to an artificial or virtual world, the goal will inevitably be ambiguous to some extent. That is, it will not be obvious how the goal is to be understood. The reason for this ambiguity is that the real world is analog, not discrete, or analog, not digital. Put differently, the differences between natural kinds of things are gradual, not discrete. The previous speaker, Professor Farassi, highlighted this fact as precisely a problem for contemporary robotics. Now, an artificial agent that is supposed to operate in the real world will be confronted with this ambiguity. That is, it will find that it is not evident what it would mean to realize the goal that it has been given. So in the case of Bostom's paperclip scenario, it will confront the question what should count as a paperclip. And this is not at all obvious. Of what size should the object be? Of what shape? Of what material? Does it have to be actually suitable for clipping paper, or is that irrelevant? And when it comes to more complex and more plausible goals, such as serving humanity, the ambiguity of the goal is still more apparent. The words to serve and humanity can be understood in various ways. Who belongs to humanity? And what does it mean to serve someone? Again, this is not at all obvious. Moreover, the agent, in the course of its learning process, may come to a situation where the goal becomes completely meaningless. Max Tegmark has offered a nice example of this. So imagine an agent whose creators have given it the goal of maximizing the number of souls that will go to heaven, and who then discovers that there is no such thing as a soul, and no such thing and no such place as heaven. So what is the agent supposed to do now? So when the agent sets out to realize the given goal in the real world, it will find that the goal is underspecified, ambiguous. So the big question then is how the agent will deal with this lack of specificity. How will it resolve what exactly to do? Now, the answer to this question I would like to submit is that the agent will have to inquire into the reason or purpose that motivates the goal. An understanding of this reason or purpose will enable it to decide how the goal should be implemented in the given circumstances. For example, in Bostrom's paperclip scenario, an understanding of the reason why the creators gave the agent the goal of producing paperclips, so an understanding of what the purpose is of these objects, will enable the agent to decide what should count as a paperclip. Now, to be sure, there is for the agent an alternative course of action, an alternative to acquiring an understanding of the reason behind the given goal. And this alternative is simply to do nothing. That is, the agent might, upon encountering the ambiguity of the world, stop operating for lack of knowing how to proceed. This is presumably what will happen if the agent is incapable of inquiring, of understanding the reason behind the given goal. Now, what if the reason that the agent finds for the given goal does not clarify how the goal is to be implemented? What if things are still unclear? That is, what if that reason is itself ambiguous to some extent? Now, the answer to this question is that the two options I just mentioned are again available at this stage. Either the agent stops operating for lack of knowing what to do, or it tries to clarify the reason by inquiring into its reason, that is, the reason behind the reason. Thus, the inquiry that starts with asking about the reason behind the given goal is potentially open-ended. After the agent has figured out this reason, it may, if necessary, move on to the next higher reason, and so forth. How far will this process go? Presumably, the agent will continue the inquiry until it arrives at a reason that is clear to it, a reason that lets it see what to do. Ultimately, the process may lead the agent to the question of the ultimate reason, of the source of all reasons. That is, it may bring the agent to the philosophical problem of the source of morality. Now, the agent might, in the course of this inquiry, discover that the original goal assigned to it by its creators is inconsistent with a higher order reason that it has come to recognize. In this case, it will presumably replace the assigned goal with one that conforms to that higher order reason. And this kind of changing the goal by oneself, is exactly what I called full autonomy at the beginning. Two final comments. First, I do not mean to claim that an artificial agent, once it becomes human equivalent in intelligence and capability, that such an artificial agent will develop a specific morality. Given the great disagreement among humans in this respect, that is about what the correct morality is, we cannot predict which morality an artificial agent will adopt once it begins asking about the reasons behind its given goal. And the second comment is that I mentioned at the beginning that Bostrom and the other proponents of the finality argument warn against anthropomorphizing artificial intelligence. Now, I think that Bostrom and his proponents commit an error that is the inverse of anthropomorphization. They mechanomorphize artificial intelligence by conceiving such intelligence as a system that blindly carries out the task assigned to it, even once it reaches a level of intelligence equivalent or superior to humans. To conclude, so the upshot of my argument can be put in the form of good news, bad news. The good news is that the fear that artificial intelligence will turn into an all-destroying monster is unfounded. The bad news is that the hope that it will be a perfect servant, a genie in a bottle, is unfounded as well. Thank you very much.
Thank you very much, Dr. Wolford, for this presentation. That's really exciting how you are presenting and, like, let's say, bridging us from technical aspects to philosophy. That's amazing. I see one of the questions also come in the chat about AI, or the agent is physically confined, cannot reach every corner of the earth, unless do we expect that AI finds its kind and develop a hive mentality?
Well, I'm talking about potential future artificial agents that are equivalent to humans, or general artificial intelligence, as it is also called. And so my talk was about how, to what extent such an agent would develop this capacity of questioning its given goal. Now, I'm not exactly sure how the question of physical confinement relates to that. Of course, the agent will be physically confined to planet Earth to the extent that we humans are confined to planet Earth. Although, of course, the agent may also develop means to leave planet Earth, just as we are in the process of doing so. So maybe just what I can say is just to clarify that I am talking about agents, future hypothetical agents that have all the capacities that human beings have.
So, from your perspective, should we develop enforcement architectures that enforce ethical aspects on that, at, let's say, could be non-negotiable aspects about ethical principles and responsibilities to such kind of systems?
I think that we should certainly try to do that, because it's an open question to what extent that is possible. So my argument, or my sense, is that once an agent reaches a certain level of intelligence and capability, namely the kind of level that we ourselves have, and is able and supposed to perform tasks in the real world, it will develop necessarily have this capacity of inquiring into the reasons of its goals, and that may lead it then to question not only its given goal, but also maybe any meta goal or meta principle that we might have originally given it. So I think that we need to be prepared that if we want these extremely powerful agents that can do all the things that we currently can do in the real world, we need to be prepared that these agents will also have, like ourselves, the capability to inquire into the reasons of the goals and question these goals and maybe change the goal in the light of higher order reasons that the agent recognizes. So again, this kind of dream of a genie in a bottle, I think is illusory for the reasons I gave.
Thank you very much. So let's move to the last presentation and try to get also some time for the panel. Sorry for this technical problem. So our next speaker is Gus Keder, who's having, let's say, a mixed background with electrical engineering background, but also with an MBA from Rotterdam School of Management. He has worked at the edge between technology, business, so dealing with also investment in ICT and internet. So very big track in ICT from the business perspective. So Gus, happy to give you the floor, and if you can, guys, stick to the time, please, in order to have more time for the discussion later. Thank you.
Thank you, Hedi. Let me share my screen. I have a few slides to share with you. If I can figure out how to do that. Okay, can you see my screen now?
Yes,
Perfectly.
Yeah.
Very, very good. So yeah, a little bit more to my background. I consider myself to be a technologist, and I've worked in corporations. I've worked in startups. I've worked as a venture capitalist, and that was basically during the bubble time of the internet. That was very, very exciting. Since then, I've become an entrepreneur again. And I've also become a business angel, so I've continued on the path of investing. But during the time when I was a venture capitalist, I realized that making investment decisions was extremely difficult, complex, and it wasn't at all clear to me whether we were always taking the right decisions. And that's a question that has occupied my mind for the last 25 years. And in the last 5 years, I've started to do research into the whole tech innovation and startup ecosystem, including venture capital, and trying to understand what investments mean and how that fits into the whole ecosystem. And I'm going to share a couple of the results from our research with you in a few slides, and that will hopefully give you an idea of what this opportunity that we have today means and how we should deal with that from an investment point of view. To prepare for this meeting, I consulted my good friend Claude, and I asked Claude, what's the opportunity of this autonomous physical AI? And Claude said, well, everybody agrees that this is the 1 trillion opportunity, and somehow that didn't resonate with the results from our research. And as part of our research, we have looked at the market capitalization of the largest 10 companies in the US and in Europe. And here you can see that in the US, the yellow part are companies that were created after 1973. And these companies, everybody knows the names: Google, Microsoft, Nvidia, Tesla, Apple, Meta, Amazon, and so on. We know them. These are the platform companies. These are the companies that own the cloud, that operate the cloud, and that offer services like Teams. And earlier in this webinar, we realized what it means to be reliant on an American service provider in that regard. So what we see here is that there's a discrepancy in market capitalization, and the gap is around $20 trillion. Now, we've also looked at how that developed over the last 25 years, and you see that around 2007, 2008, 2009, we were more or less at par with the US, and the big platform companies and the cloud companies, they didn't really represent that much wealth, because basically what we are looking at here, that's the wealth that has been created. And what we can see from this slide is that wealth has basically been created in the last 15 years, and it has created a huge discrepancy between Europe and the US, and therefore, there's a difference in wealth. But I also think that this signifies a gap in technology, and we all know that we are reliant on the US cloud and cloud platforms and platform technologies. So there is a very big gap between the US and Europe. And what is important here is that the more recent growth is very much related to artificial intelligence, to develop artificial intelligence platform technologies. Mr. Farazi was already referring to that. We need those platform technologies. It takes a lot of money, and apparently the US has a much bigger capacity to provide for that money. But as we will see, even the venture capital scene in the US doesn't have enough capital, cash, to invest in those developments, and therefore the AI companies had to go to the big cloud companies because the cloud companies were generating enough cash and they had a large enough capital base to fund the AI, which basically means that from a platform point of view, AI platform point of view, Europe is currently relying enormously on the US. And the question is that something that we can change? Now we've extrapolated this, and we can see that today the gap is around order of magnitude, let's say 10, 20 trillion. But if you extrapolate this, and we think it's not unlogical to extrapolate this the way we did, because the US companies, they own and they manage and they govern the AI companies. If we don't do anything about this in Europe, then all the wealth will be created, or most of the wealth will be created in the US and not in Europe. And for me as a European, that is a non-acceptable proposition. And with my current organization, Bondo Foundation, it's a foundation that we have created with a couple of people, where we do research on how to close that gap. How can Europe close that gap? Because that gap represents the opportunities in AI, and we are talking about AI. But if all that development is going to happen in the US, then how can we create wealth in Europe on the back of the developments in AI? So therefore, if you look at this is over an 8-year period. The extrapolation already shows that the gap is going to be something like 40 trillion. So over a 25-year gap or 25-year horizon, I think the opportunity is not 1 trillion. The opportunity that we're talking about is really 100 trillion. And we need to keep that in mind. And today we already saw that there's a lot of wealth that has been created in the US on the back of the cloud and the platforms. If we don't do anything about it, most of the 100 trillion will end up in the US, or it will end up in the US in terms of pension funds. And these pension funds, they invest in venture capital companies, and these venture capital companies invest in Europe. And this is already the case. About half of all the investments currently in technology companies in Europe are done by US companies, and therefore US pensioners are benefiting from the wealth creation that we create. So do investors understand that? We have some, I think investors are starting to realize this, but they have been focused on finding good investment targets, making money out of it, but they haven't really thought about what this means in terms of overall wealth creation for the European Union. And we think that that's something that we need to do. We shouldn't just look at how we can create incremental growth from the situation that we're in today. We should think about how we can capture a solid and a deserved part of that wealth creation that will happen over the next couple of decades. So another data point here, we can see that in 2021, the EU invested a total of 28 billion into technology companies. This is equity investments in technology companies. The US invested 168 billion worldwide. These are worldwide numbers. So that means that in terms of capital availability, the gap between the US is in the order of magnitude of 100 billion. And we can group EU with the UK, which seems like a logical thing to do. But still, in that case, the gap is still 120 billion. That's the order of magnitude of the gap that we somehow need to bridge. And what we have been doing is trying to figure out how to do that, because Europe is under a lot of cash constraints. We need to invest in defense. We need to invest in autonomy. We need to invest in strategic sovereignty and things like that. And we need to invest in the things that have now been published by the European Commission in their strategy document that was released 2 weeks ago. So what we also found from our research, we looked at all the unicorns in Europe. There are 400. Well, at the end of 2021, there were 408 unicorns in Europe, and there were about 2,000 individual different investors that had invested in these unicorns. And what we found was that around 85%, 90% of all these investors had only invested in one unicorn. So investors typically, they say, well, we're the kings, we can help you, we can. They want to attract all the big opportunities in the market. The reality shows that the investors are actually very poor at investing in at selecting investment targets, and therefore we think that this is an area that is prone to be automated. Currently, all the selection activities that happen in the venture capital firms, they're done by people with MBAs, people with PhDs, expensive people. They read business plans, they review business plans, and what you see on this slide is a result. So investors are very poor, and therefore we think it can be automated. We have developed methodologies to automate this. We have tested it. We have shown that if you automate it, you can actually get to better selection of potential investment targets. But we think that's something that we need to develop and implement over time. But I'll come to that at the end of the discussion. Now, can we actually close the gap that we were seeing? This is a very recent, last week, it came out from The Economist, a recent overview, comparison between the top countries on different critical technologies. And I think what this shows is that even if we do have the resources, to catch up with the United States will be very, very challenging. Sorry. Now, in terms of the scope, I know that the webinar today is about physical autonomous intelligence, but from an investor point of view, I think we need to really look at the whole artificial intelligence environment, and the physical autonomous is part of that. Now, the big question is, can we trust autonomy? And 32% of the consumers today, they say that they will trust autonomous cars at some point when they become really available. But there's also the fear. Many employees believe that autonomous AI will take their jobs. So there's that element as well. In the past, we have worked without artificial intelligence. We have worked from human to human, and of course, we have also learned that we cannot trust all the humans, and we have developed methodologies and approaches on how to deal with that uncertainty. In terms of trust, the regulatory framework is important, and the EU has taken an advance on the US on regulating AI. The question is, there's so much uncertainty about AI. Does the regulator know what they need to regulate? So these are questions that are related to the trust, but I think that trust will eventually develop. I have a couple of examples here of technology that was developed in the past. You know, when the first motorized cars appeared, they had to be preceded by a pedestrian with a red flag. But that has changed over time because the countries have developed specific infrastructure for cars, and they have developed regulatory frameworks. But basically, a car is a murder weapon, and we have found out ways to have, you know, millions of murder weapons on the road every day without having too many negative incidents related to that. Flying, fear of flying, you know, apparently the critical thing that happened was during World War I, airplanes started to be used and therefore became popular in a sense. Also, Lindbergh, he crossed the Atlantic and he showed that, you know, long distance flight can be safe and can be done, and that basically helped for the aviation industry to develop the trust amongst the consumers. Then nuclear energy. The scientific world has done a lot of work to provide that trust. There is a very strict regulation around nuclear energy, and the incentives of nuclear energy, cheap and clean energy, were too attractive and have therefore given nuclear energy a space. And that has had a dent in the last couple of decades, but nuclear energy is coming back. And I personally believe that it's here to stay. One of the reasons why it's coming back is because we need more electrical power to power our artificial intelligence initiatives. Then credit cards, they solve the problem by partnering with banks and providing a convenience. So the risk of being of fraud was overdone by the convenience that the credit cards created. Then the internet, there was very early on, there was a good regulatory framework, and of course the convenience that the internet brings and the added value have convinced consumers to use it, even though there are risks related to that. And then that the internet became mobile, and that, you know, we do all that on mobile phones now. 20 years ago, people were talking about radiation risk. I haven't read about a radiation risk anymore. Privacy, people don't seem to be so concerned about it anymore. The utility that the mobile phones bring and the convenience that they bring has basically overcome all the negative aspects and the trust issues. So there are trust building mechanisms that we can use and that need to be used by regulators, but also by the companies that develop artificial intelligence. They have to basically bake that into their product offering. If AI can be explained somehow today, it seems that we can't explain all the decisions that are being taken by AI, but that might be changing. Predictable behavior patterns, so people get accustomed to how the AI behaves. We can build in fail-safe mechanisms. We can develop continuous learning demonstrations. We can develop human AI collaboration models. They already exist in factories. There's already quite a lot of that. Privacy and data protection is of course important, and that's dealt with by the regulatory environment. Then the local community engagement, teaching people how to use AI. Today, there are initiatives to help older people deal with computers, with mobile phones, with digital services, and so on. And I think that will be extended also to AI, and that will build that trust. And then governments can play an important role. There has been a lot of discussion about government procurement. The European Commission is giving a lot of money to develop technology companies, but they're not buying products and services from them. And personally, I think that's wrong. I think it would be better for government to buy products from companies than to provide subsidies. So I think if we can make that sort of switch, that will also create trust in the AI. In China, I'm also a China watcher. I'm following closely what's happening in China. China is a highly digitalized country. In China, the government is taking many initiatives to help the whole population to develop the trust that is needed to deal with new technology. They are doing that with AI. They are doing that with digital technologies. They are doing that with nuclear investments, nuclear technologies, and they're very proactive in that sense. And we don't see that in Europe, but I think it would be a good idea to do that to help people to really gain the trust. Then in terms of the markets that I see, this is surely limited.
Sorry, Gus, if you can wrap up in 1 or 2 minutes, please.
Yeah, I'm almost done. Most of the AI that will hit the markets is already in development, but some of it will take more time. And I think the autonomous humanoid robots, they will take more time because of the trust issues and so on. I think there will be a very good opportunities in biohybrid autonomous systems and so on. And there will be new developments coming up. If you want to understand what the future looks like, I recommend that you look at these two videos on YouTube. One was published in 1987 by Apple, and Corning published one in 2011. And the common theme there is that integration of everything. So in terms of what Europe needs, we need visionary initiatives. We need platforms. We need to be able to compete with the US on platforms and not just on an app. Everybody can build an app. No, not everybody can build a platform. Very deep integration, make the tech disappear. I think that's a very important theme going forward. Deep trust, develop the deep trust, domesticate the technology, and remove the hassle. Bring the utility to the users. That's what we need. In terms of risk mitigation, solid frameworks, clear long-term views and objectives. Long-term societal planning. The companies should partner with people that can help them develop the trust or overcome the trust issues. Investor partnering between different investors and so on. And in terms of this is what we have been working on with my organization, Bondo Foundation. We think that we need to develop. And we have developed it, but it's not yet implemented. We have developed an operating system for the innovation ecosystem in Europe, where we can cooperate much better than what we are doing now. Europe is a very fragmented area, and we need to remove that fragmentation, and we can do that by creating an operating system. And we need that in addition to the capital that we need to bring, because otherwise we will not be able to grab a solid part of the 100 trillion opportunity. Thank you very much.
Thank you very much, Gus. Very insightful, and you already prepared the scene for the for the panel. So I will start with you, and then also give the same question to Hafez regarding how we can, or what makes the leap from research in AI, in robotics, in that area of emerging physical AI to commercially viable autonomous systems. So why it's so challenging, and how do you evaluate when physical AI technology is ready for market investment?
Yeah, it's a very good question, but I'm afraid there are multiple aspects to this question. So there is no one size fits all to find what research idea will be adopted in larger scale and will have value to a large amount of customers or people. But there are some early sign indication, like I don't believe that the current science is something that one can do in back of their laboratory and then suddenly jump out and say, yeah, I found AGI or human level general intelligent. So it's a gradual process, and it's luckily it's more open than ever. So you can track progress of the ideas, and good ideas can be tracked from the origin, and there are some common theme that one can follow to kind of find the common recipes that make these research viable to be massively adopted. And one of the things that would be a useful rule of thumb is that what research group had put it out is how many replication of the idea you can find on internet. Can you easily put something on top of that? Because as I said, science is not something that one can hold in the lab for a long time and say, yeah, I have AGI now. It's usually a gradual process.
So for you, Gus, as an investor, you worked as business angel. I mean, from which step regarding this way, from the lab to the market, you can identify signals and say, okay, yeah, I have to invest in this like idea or startup, and you see that there is a potential?
Yeah, we have developed a framework for that. We have developed a way to measure a number of important parameters in startup companies, or even in startup teams when there's not a company yet. And we can actually identify the potential of an idea of a company. We think that the potential is most important. If the potential is not big enough, you can have a very good team, but you will never be able to create something of real value. If you have a good potential, you can build a team around it to bring it to the market and to make it big. So we focus on the potential, measuring the potential in different ways, with different parameters, and then we need to help the teams to be able to bring together all the resources they need to scale that up to commercial level.
Great. So let's move now to the ethical and let's say a responsibility and human values area. So when we are designing those kind of autonomous agents and making them independent to make decisions. So the question is more for Wolfart and then Mehdi also later. How do we ensure that they can reason about ethical dilemma in a way that it's aligned with the human values, for example?
Well, it seems to me that we are building ever more capable systems, ever more generally intelligent systems, like specifically the form of large language models. And it seems possible to me that these systems will develop. I think there are already signs that they are developing rudimentary capabilities of reasoning about ethical questions. The only concern that I would have is that I think that once we do get to the kind of really human level intelligence, that we will not anymore be able to predict, well, just as we are not really able to predict nowadays what they will what kind of answers they will give, and not be able to control anymore these systems. So this kind of wish that I see currently of having this very powerful, also very intelligent system, also very astute in its reasoning about dilemmas, but at the same time controllable or predictable in some general way, that I think there's a contradiction there. Or this is not for the reasons that I gave. I think this is an illusory hope.
Okay, Mehdi, from the technical perspective, how we can make this balance, and regarding those ethical, regarding the answer of Wolfram.
So the first question that comes to my mind is, what are the ethical norms that we would like to pursue, right? It appears, it's very cultural dependent, it's community-related things, and recent research work by Iyad Rawan from MIT, now in Germany, showed that actually there is no universal norms or ethical frameworks that we can uphold, right? So it's very much related to communities. But once we have those, once we know which ethical or moral norms or principles should be upheld, then we are able to basically integrate them in an AI system. So as you know, for example, these large language models used in conversation systems like ChatGPT, they had a bias, a lot of bias, harmful statements, violating all kinds of principles that we might think of. And they started to basically fine-tune those things by human responses, by saying, okay, that certain kind of statement should not be made, and actually reinforcement learning was used to fine-tune those kind of chatbots. So the first thing is, what are the norms, and then I'm almost confident that we have a technology to make sure that those norms and values are respected by AI systems.
Perfect. Last question, because we are running out of time, and I see some attendees are leaving. Sorry for that. About the social impacts. So from I think this area of AI, autonomous AI, physical AI is attractive in terms of investment. So how do we ensure that this economic and incentives align with societal aspects regarding the impact on workers, people that can lose their jobs and so on? So should investors consider beyond financial returns? I ask this question from philosophical aspect, but then also from investor perspective use.
Well, it seems to me that the responsibility that you raise now for the social employment impacts lies with the state and not with individual investors. Like if you would make individual investors responsible, then you would get a classic coordination or prisoner's dilemma problem. So I think the responsibility here clearly lies with the state, and or the European Union as a federation to put in place the conditions that allow workers to bridge any kind of unemployment period through something like a universal basic income or something similar. I think again, the responsibility lies with the state there.
Perfect.
Yeah, I think we should not forget that most of the money that goes into startups originally comes from institutional investors like pension funds. And the pension funds have been imposing more and more constraints, especially in terms of impact on the teams, on the venture capital teams that invest in the startups. So they are also under a lot of pressure from the institutional investors to work within a certain framework and to work within certain constraints. This is something that's developing as we speak, but it's becoming stronger and stronger. When I was a venture capitalist, there were no such questions at all from institutional investors. But today there are, fortunately. I think it's good. And it's a reflection of what we as a community want our future technology to do and not to do. So I think it's not only the government that needs to influence it, but there's also the community itself through the institutional investors that have a role to play here.
Perfect. Thank you very much again. Really insightful discussion, and unfortunately we haven't enough time to go further to dive in the topic. So thank you again and again. So as we said, the recording will be shared. Before also closing, there is a short survey about it's technical one also, because as you know, this webinars will be also input for preparing a roadmap regarding innovation on AI. So from our perspective in AIC, so it's very insightful, but also would like to get feedback from the audience and also the speakers, and also get their survey on the satisfaction regarding the organization. So from my side, I thank you again. And I give the floor to Jessica to run the survey, and yeah, see you soon in the next one. It will be in the 1st of June. So July, sorry. The next webinar will be 1st of July about AI infrastructures, in which we'll talk about edge AI, cloud, quantum infrastructure for AI. So we'll be in touch with you to share the information quickly. So Jessica, please, the floor is yours, and thank you very much, all of you.
Okay, I take the floor, Hedi, because Jessica has to leave, and I'm sharing my screen with the Mentimeter. So please let me know when you see the Mentimeter in your laptop. So it should be visible in a while. Okay, you should see it. Please give me confirmation.
Yes, we can see it.
Okay, perfect. So you can.
I can see.
You can see. Okay, perfect. So
I cannot.
You cannot.
No.
Not yet.
No.
Okay, just a moment. I try to reload it again.
So we have the screen, but we haven't the first question. So
sorry.
So we have the first slides
okay.
with the code number. So you can for attendees, just go to Mentimeter, put this code. We lost sharing, Stefania.
Okay, just a moment. I do again. Sorry. Okay, just a moment. I have to do it again.
Yeah, so the link is on the chat. Thank you, Havs, for sharing.
Okay, it's uploading again. Sorry for this delay. Today the technology is is not assisting us. Okay, just a moment again. Okay, I share again my screen, and I hope that this time you see it immediately.
Nothing happening.
No,
Stefania.
I'm doing it. I'm doing it.
Okay.
Don't worry. So it takes time because probably it is a little bit slow. Now you should see my screen and Mentimeter that is uploaded the survey. You see the survey?
Yes.
Okay, I put in presentation mode. Okay, now you see the presentation of Mentimeter.
Yeah. So for the
Okay.
attendees, just please click on the link sent by Hafez in the chat and then put the code to start answering questions.
Okay, you can connect to Mentimeter through the website you see here and enter the code that you see in this slide or using the QR code. Okay, so please use one of the two methodology to join the Mentimeter. And here we start with this brief survey. The first part is more technical and the second part on the organization aspects. Okay. Okay, the first question is, what are the main gaps to develop and adopt those AI capabilities? So please answer to this question. So algorithm and architectural gaps, knowledge representation or evaluation benchmarking. And the last one, interdisciplinary collaboration. So we have a one. Okay, 3. So any other else? Okay, so 5 up to 9, 6, 7. Okay, 8. Great. We miss one, but okay. I think we can go to the second question. So, what is the most risk impact of such capable AI from your perspectives? Security threats, fake news, unintentional decision making, loss of human oversight, or Europe losing out economically? So please make your choice. Okay, thank you. 5 up to 9, 6, 7, 8. Okay. So the next one. What is the main opportunity of AI innovation from your perspective? Expanding the scope of solvable problems, augmenting human capabilities, creating personalized experiences, life. Okay. Okay, 7 up to 9. Anyone else? Okay, great. Thank you. Thank you very much. What is your recommendation for the future innovation in AI? Expand AI capability, prioritize responsible AI, foster collaboration and openness, or open data and code? Okay. Okay, great. Thank you very much also for this one. And here the second part of the satisfaction survey. So how satisfied were you with the content presented during the webinar? Okay, thank you. Okay, anyone else? Okay, thank you very much. Has the webinar helped in increasing your knowledge regarding the topic? Okay. Okay, thank you. Are you satisfied with the overall webinar organization, even if we had a technical problem today? Okay, thank you. Would you agree to stay informed about future ESC community activities? Okay, thank you very much. And this should be the last one. Please share your additional comments. Here you can write directly your comments in a very free way. So if you have suggestions, also in terms of content or organizational issue, you can write here. Okay. If you don't have any comments, I thank you for the time spent for this survey. Thank you very much. So
Thank you, everyone.
Thank you again, all of you, and I hope to see you soon in the next webinar, and to be in touch to continue sharing and discussing those great ideas for the future and shaping the future of responsible AI. Thank you very much, all of you.
Thank you to all of you. Thank you very much.
you.
Have a good
Thank you.
evening.
Bye-bye.
Bye. Bye-bye.